Hello, my lovely viewers. You're welcome again to my channel. In this video, I'm going to talk about something very important, and I'm going to talk about protection in electrical wiring. All right, so we all know that in an electrical wiring, protection is very key. There must be a means of protecting the electrical wiring from excess current, and there must also be a means of protecting the users of the wiring from any electrical hazard. There are various types of circuit protection devices that are used to achieve this protection. And some of these protection devices are the MCBs and then RCDs. And for optimum protection, you must be able to know how to select the correct sizes of these circuit protection devices and also how to correctly install them in your wiring. I will explain in details how each of these circuit protection devices work and how to properly install them. But for the meantime, in this video, as I promised in my previous video, I'll be talking about how to select the correct size of miniature circuit breaker to protect a particular load or to protect a particular circuit in your wiring. So first of all, what is the miniature circuit breaker supposed to do in the electrical circuit? The main function of the circuit breaker in an electrical circuit is to ensure that the supply is cut off from the circuit or the supply is cut off from the load anytime there is an excessive current flowing through the circuit that the breaker is connected in to protect. All right. And this happens automatically when there is a fault that results into excess current through the circuit. So the main function of the circuit breaker is to make sure that it switches off the circuit automatically whenever there is a fault or whenever there is an overcurrent flowing through the circuit. Okay, so what is a circuit? Basically, in practical terms, an electrical circuit comprises of a source of supply and electrical cables connecting that supply to an electrical load. All right, so when we talk of a circuit basically involves the cables and then the loads that are connected for a particular purpose. And in an electrical wiring, there are different sizes of loads depending on the current that those loads require to work. Example, in a typical domestic installation, we need electricity to power our lamps, our fans, but there are other items also like the fridges, the microwaves, the pressing iron, the blenders that we also need power for. Now, some of the loads in the wiring need very little amount of current to work, whilst others also need higher amounts of current to work. So for instance, normally in an electrical wiring, we usually have the lighting circuit and then we have the power circuit. The power circuits involve those items that are normally plugged into socket outlets like the fridge, the microwave, the pressing iron, the blenders, and all other items that are usually plugged into socket outlets. Then we also have the lighting circuits, which involve the lights we use, the fans, and other things that require just a little amount of current to work. And that is done to make sure that, to some extent, all the loads in the circuit have some kind of protection against excessive current, because the amount of current that will cause a lamp to blow will not be even enough for a pressing iron to start working. And so if we are talking of protection, we cannot connect both the lights and the sockets in the same circuit. So in every electrical installation, there is a distribution board or a consumer unit which houses the breakers that protect the individual circuits in the wiring. So when you open the distribution board, you see different sizes of circuit breakers in terms of their current ratings. And mostly, the standard sizes of circuit breakers that you may find in an electrical installation are 6 amps, 10 amps, 16 amps, 20 amps, and so on, depending on the size of the installation. All right, so these ratings are the usual ratings you will find. Though there are circuit breakers that have smaller ratings, they are not common and they may not be readily available on the market. So these breakers in the distribution board are connected to individual circuits depending on the amount of current that the loads in that circuit need to work. And the function of these circuit breakers is to make sure that everything in that circuit, the cables and the loads, are all protected from excess current. All right, so now that brings us to the big question. So, how do I know the correct size of breaker to protect a particular circuit? In order to be able to select the correct size of breaker to protect a particular circuit, there are things you need to know and there are things you need to consider. First of all, you must know how much the load or the number of loads that are connected in that particular circuit require to work. So you must know the total amount of current required for the loads in that particular circuit. Then secondly, you also have to know or you have to have an idea of the current carrying capacity of the cables that are used in wiring that particular circuit. So the third thing to do is that you make a list of all the sizes of circuit breakers that can be used to protect the cables that are used in that particular wiring. If you are successful in listing all the breakers that can be used to protect the cables in that circuit, then the next thing to do is that among the list of breakers you have, you now select the least rated breaker that has a rating not less than the total amount of current that the load will require to work. In case you want to know more about how to determine the current carrying capacity of a particular size of cable, you have to refer to my previous video that I titled How to Select the Correct Size of Cable. All right, so let's look at a practical example. I have an electrical wiring for a lighting circuit, and the size of cable that is used to wire this circuit is 1.5 millimeters squared, copper conductor, PVC insulated, and the ambient temperature is assumed to be 40 degrees Celsius. All right, so with this information, I know the current carrying capacity of my cables will be around 12 amps. And I have 13 lamps wired in this circuit, but the lamps are not of the same size. There are different types of lamps. 4 of the lamps are rated 24 watts each, and then 8 of them are rated 5 watts each. Then I have a chandelier that is also rated 125 watts. I want to connect all these lights in the same circuit. But before I do that, I have to calculate to know how much current all of them will require to work. And then based on that information, I can now select the correct size of breaker to protect that circuit. So now 4 lamps by 24 watts will give us 96 watts. 5 watts by 8 lamps will give us 40 watts. And then the chandelier will also give us 125 watts. In order to know the total power that will be consumed by these lamps, we have to add all of them together. So now we have 96 plus 40 plus 125. And the total power that will be required by these loads to work is 261 watts. Usually, the commonest parameter that is stated on the load is the power that the load consumes. And so you may not have the current stated on the load directly. You may have the voltage and then the power that it consumes. And so from those two information, you can now calculate the current that will be required by the load, or the current that will be consumed by the load. All right. Now we know our total power that will be consumed. As for the voltage, it depends on your jurisdiction. It is constant. For instance, in Ghana, the single phase supply has 230 volts. Elsewhere, the single phase supply has 110 volts. So it depends on your jurisdiction. So knowing the power and then the voltage, to find the current, you have to divide the power rating by the voltage. So in this case, we are dividing 261 watts by 230 volts. And that gives us a current of 1.13 amps. All right. You must make sure that the total amount of current required by the loads is lesser than the current carrying capacity of the cables that are used in the wiring. That is the first thing you should consider before coming to select the breaker. If you calculate and you know and you are sure that the current required by the loads to work is below the current carrying capacity of the cables that are used, then you can go ahead to look for the correct size of breaker to protect that circuit. So in this example, our load requires a current rating far less than the current carrying capacity of the cables. And so we can now go ahead to look for the correct size of breaker to connect in this circuit to protect the cables and then the loads. So now, in the list of standard breakers, we can only use up to 10 amps breaker in this particular circuit, because per the standard ratings we have 6 amps, 10 amps, and from 10 amps you go to 16 amps. And because our cables can carry up to 12 amps, we don't want to select any breaker that has a rating more than 12 amps. All right, so 10 amps is the highest breaker we can use in this particular circuit. But in the list, we have 6 amps and we have 10 amps. So which one are we using? Though we can use any of these two breakers in the circuit, one will do us more harm than good, because to some extent the miniature circuit breaker should be able to protect the lamps from excessive current. And so, for instance, the lamps that are rated 5 watts, it requires only a very small amount of current to work. And so for that 5-watt lamp, even 2 amps will be seen as an excess current that can spoil the lamp. Now, to some extent, we want to protect all these lamps as much as possible by the use of the miniature circuit breaker. And so what we have to do is that we have to get a breaker that has a rating that is not too big than the total current rating of the loads that we are protecting. So in this particular circuit, for the total amount of 1.13 amps, the best breaker that we could have used in this circuit to protect the circuit is a 2 amp breaker. But then, practically, it may be difficult to get a 2 amp breaker. And so the common ratings that we have may start from 6 amps. Because you cannot get a 2 amp breaker, you will have to use 6 amps to protect this circuit. But the best breaker to protect this circuit should have been a 2 amp breaker. Now, if you want to use 10 amps breaker to protect this circuit, what you are doing is that you are protecting the cables all right, but you are not offering a bit of protection to the loads that you have in the circuit. But no, in order to protect a circuit properly, the circuit breaker should be able to protect the loads that are connected in the wire or in the circuit. So if you want to select the correct size of circuit breaker for a particular circuit, this is how you go about it. Now, in the case where you have a single load in the circuit, for instance, a cooker circuit, the same procedure is what you have to follow to select a correct breaker for this cooker circuit. All right. So let's assume we have a cooker that consumes 3000 watts. The voltage is constant. So if we want to know the amount of current that this cooker will consume, we divide 3000 by 230 volts. And so 3000 divided by 230 volts gives us 13.04 amps. All right, so now we know the amount of current that our load requires to work. Now, this current must not be more than the current capacity of the cables that are used to wire that cooker. So in this case, if we are using a wire that can carry up to 17 amps, looking at the factors around your wiring environment, then you can only select circuit breakers that have ratings below 17 amps. All right, so from the standard rating of circuit breakers we have, under 17 amps, we have 16 amps, we have 10 amps, we have 6 amps. So these are the list of circuit breakers that you can select from to protect this particular circuit. The breaker you select for protecting the load shouldn't have a rating that is higher than the current capacity of the cables in the circuit. Then it must also not be too higher than the current rating of the load that is connected in that particular circuit. All right, so in this case, for our 3000 watt cooker, we can use 16 amps to protect that circuit. And that is the correct size of breaker to use for that. In that case, you have only that cooker in that circuit. All I have talked about the miniature circuit breaker has to do with protecting the equipment in the wiring. What about the human beings who use the wiring? There must also be a protection against electric shock, which can cause electrocution. Now, most of the causes of electric shock in an electrical wiring are leakages that may not be enough to trip the miniature circuit breaker. So there is the need for us to use additional protection that will protect the users of the wiring from electric shock. And the commonest device that will help us to achieve this protection is what we normally call the RCD. All right, so for protecting your circuit, you need the MCB. For protecting the users of the wiring from electric shock, you need the RCD. All right, so what does the RCD do? How does it work? What are the ratings of the RCD? Which one do I need to use to protect my circuit? All right, so these questions and many others will be answered in my next video. I'll be talking about the RCD and I'll tell you everything you need to know about the RCD. Please, if you have learned something from this video, if this video has been useful to you, click on the like button, share to others to also benefit, and I suggest that you subscribe. so that you'll be notified when I upload my next video.